Hello students, I'm Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry the Mystery of Molecules. Today's topic of discussion is actually green ammonia. By the way, green ammonia doesn't mean its color is green. I want to say that its production strategy is associated with zero CO2 emissions. So environmentally friendly or less polluting. You may think in this way. It has a very high impact in global warming and climate change. Why? Because this ammonia molecule could be used as a fertilizer, and that is very important for food security and sustainable future. So it's a very interesting topic, but before going to details, one MCQ for you. I request everyone, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's start now. What is green ammonia? If you look at ammonia, it's actually a pungent gas that is widely used to make agricultural fertilizer. Actually, green ammonia production means the making of ammonia is 100% from renewable sources, or you can say, sir, carbon free or CO2 emission free. Technically accurate statement. Now, if you look at one of the process of green ammonia making is actually you need to produce hydrogen, nitrogen, they'll react together to produce ammonia. Means the hydrogen will be produced from electrolysis of water using green electricity or renewable electricity like solar, wind, hydro, etc. And the nitrogen needed will be separated from the air because air has nearly 78% nitrogen content. So you may separate from air by different method, for example liquefaction or diffusion method. So okay, you can separate from air. Here all the electricity needed or energy needed for the process will come from renewable sources, and these nitrogen and hydrogen will react together in this next step, I mean by Haber process, to produce the ammonia. If you look at, there should not be two, there will be one molecule or one volume of nitrogen react with three molecule or three volume of hydrogen and produce two equivalent of ammonia. This is the thing. And for this process nearly very high temperature like 400 to 450 degree, very high pressure needed because two gas molecule will react together. Increasing pressure will bring them closer such that their reaction will be favored, and in presence of iron as a catalyst. And this way produced ammonia is separated by liquefaction. So in this way what we end up, liquid ammonia. And if you look at the current ammonia production globally, it is not at all student green process. Why? Because here the hydrogen is produced from methane. Means methane, water, that produces hydrogen and CO2, and in this way there is a CO2 emission. And this process is called stream methane remorphing or SMR process. And here also CO2 is produced, 90% is reutilized. But remember one thing, you have used this ammonia or urea, whatever I say, in the field. Now this urea will decompose and nitrogen may take the, means plants may take the nitrogen or ammonia, but what happens to the carbon dioxide? It will come to atmosphere. So indirectly you are emitting more CO2 in the atmosphere for this process. So this is not a environmentally good or carbon neutral. And if you look at globally, the whole process, I mean the ammonia industry or urea, produces nearly about 1.5 to 2% global warming or CO2 emission. So from there you can understand clearly these cannot be ignored. Now you can say, sir, nearly 1.5 to 2%, should I really focus? Remember, global warming and climate change is becoming a severe problem. So you need to look at every sector where significant amount of CO2 emission is taking place, and that should be reduced as much as possible. And now if you look at the uses of ammonia, these are the existing use. We will focus mainly on here. These are the expanded use, like actually in fuel cell, chemical energy storage or chemical hydrogen storage, etc. We'll discuss in some other videos. Now if you look at the consumption of ammonia currently, nearly 80% of this ammonia is used for fertilizer application, like the majority share goes to urea preparation, 55%, remaining ammonium nitrate, ammonium phosphate, sulfate, etc. So these are actually the use of ammonia in the fertilizer section. So from there you can understand that first of all urea is very important, and second thing, there are other also. Now if you think that, sir, okay, do you have any more data which supports that ammonia is very important for the mankind? Yes, look at this data. By the way, this data is little old. Current data maybe if you look at global population, it shows less than 8 billion, but currently global population is more than 8 billion. And if you look at, this is world population without synthetic fertilizers. So you may understand the nearly 50% of global population exists because of this synthetic fertilizer. And you can see here the majority contribution comes from urea, means synthetic nitrogen fertilizer. So you can understand that, okay, we need to make this sector carbon neutral. So in conclusion, for the decarbonization of agricultural sector, green fertilizers are essential. And the most important step in this context is the production of green ammonia, because it will be later on converted to urea or other nitrogen fertilizer. Next, here the energy or electricity used during this process must be produced from renewable sources like solar, wind, hydro, etc. Since the 50% of global population sustained due to such fertilizer, mainly urea, urgent focus should be provided on scientific and economical perspective of this industry. What do I mean? Technological development must be needed. Now, initially, if you want to establish an ecosystem for such kind of industry, subsidy is better. But parallel to the subsidy, technological improvement should be there such that this sector became economically sustainable in future. Means no CO2 emission or net zero CO2 emission with economic profitability. Now let's come to the today's question, that which statement explain the reason or phenomena based regarding very less chemical reactivity of nitrogen molecule. Now I have asked the reason. If you look at nitrogen, there is actually a nitrogen triple bond. Nitrogen boiling point is very low, no. Nitrogen has high electronegativity, no. Nitrogen bond energy is very high, it is the right answer. Why, student? If you look at, there is a triple bond means 1 sigma and 2 pi bonds, and these bond dissociation energy or bond energy of this nitrogen triple bond very high, means you need to supply huge amount of energy, then only you can break nitrogen molecule and you can do some chemical reaction. If you recall, the condition for this ammonia preparation is actually 450 200 atmosphere pressure. So from there you can say, sir, it's a very drastic condition. Why drastic condition? Because the bond energy of nitrogen bond is higher. Yes, I agree, hydrogen bond energy also higher, but this is a very strong bond, difficult to break. That's why you need to supply drastic condition, more energy, then only this chemical reaction will be possible and it will end up in ammonia, or you may say later on urea. And if you look at the fourth option, air consists nearly 78%. By the way, this is not the reason regarding very less chemical reactivity of nitrogen molecule. This is the consequence. Since nitrogen is chemically very less reactive, even compared to oxygen, nitrogen is more inert or less reactive. That's why air contains 78% of nitrogen. So this is not the reason. It is a true statement, but it is the consequence. So this option C is the right answer. So this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.